All right, hi guys. If you are just joining for the second video, you want to just pause the video and copy down the title. So Unit 11, Lesson 3, Polynomial Functions, and then go ahead and record whatever it is that I have for this part of the video for you. All right, so the last fact that we want to review is fact number 3. All right, so when a polynomial touches but does not cross the x-axis at x equals a, the factor form of the polynomial will have an even number of x minus a factors. Okay, so what does that really mean? All right, that sounds like gibberish. So here, here's an example. So consider this polynomial p of x, and we have all of these in factored form. And we can see that they're associated to this graph, but we want to know exactly what that means. So just recalling, right, if we set p of x equal to 0, okay, just for a recall, cool. That means we're going to set each of these factors equal to 0, all right? And we will then find the zeros or the roots or the x-intercepts. So for example, if we were to take out this one, 0 equals x minus 3, we would get x will equal 3, right? It ends up being its opposite value, right? So we remember this through zero product property. So the key thing here is we can see that this factor, x minus 3, is represented by this root at negative 3. So x minus 3 is represented here. Here we have negative 2, so we know that the factor that goes with this is x plus 2. Okay, so you can see that they're having the opposite signs. And this is x equals negative 1, but then we know that the factored form of that is x plus 1, right? And this one we don't count because it's not crossing the x-axis. Moving on to here, this is the x-intercept is positive 1, so that means the factor is going to be negative 1. Here, it's going to be x minus 2, and then here's another x-intercept, that's x minus 3. All right, so now how do we determine whether or not it's raised, if each of these factors are raised to the power of 1 or the power of 2? Now, the best way to show this is by seeing if it crosses through the x-axis. All right, so here, or to see if the function crosses the x-axis. So let me get something a little bit smaller. So right here, it crosses through, right? You don't see any bounce or a turn, right? There's no turn at the axis. So we know that this is going to have a power of 1, all right? It's going to be odd. And then here, if we go on to the next one, we can see that there is a turn here at negative 2. So when we do see a turn, or that it bounces, quote unquote, bounces on the x-axis, then, or doesn't go through the x-axis, then it's going to have an exponent of 2, or even, right? And if we continue on with this idea, the function goes through negative 1, so we know this is going to be 1. And again, moving on to our next x-intercept, this goes through the x-axis. So this is raised to the first power. Now we get to the next x-intercept, or root, and you can see that it bounces, or there's a turn that occurs here. So we know that this factor is going to be raised to the power of 2. And then the last one, right, it also turns or bounces at the x-axis. So that means this factor is going to have a power of 2. It's going to be even. All right, so in summary, if it goes through, that means our exponent is going to be odd. If it bounces, what I mean by it is the function. If the function bounces or causes a turn, then it will have an even power. Okay, and that is the summary there. Cool, so that's fact number 3. Now, why do we care about this? All right, so the goal is to write a formula, all right, from a graph, and being able to understand how to read the graph in terms of factors and even or odd powers is going to help you write that formula. All right, so here, let's focus in on kind of what we know. So the first thing is to identify the zeros, right? And so here, the zeros are at negative 3, negative 2, That's not a 0, does not cross the x-axis. Do not get fooled by that, although there are always somebody. But it's okay, we're learning. So here we have also at 2. So that means that the factors are going to be x plus 3, right? They're the opposites. The factor for this one's going to be x plus 2. And then the factor for this one's going to be x minus 2 because it's the opposite of positive 2. Sweet. Once we found the factors, we are almost done. Now we have to figure out, well, do each of these factors have a power of 1 or a power of 2, an odd or an even function power? So we look to see here, again, this goes, the function crosses through here. There's no turning point at the 0 or the root. So we know this is going to have a power of 1. All right. And then if we keep going here, this goes through the x-axis. Again, there's no turning point that occurs at the root. So it's also power of 1. And then lastly, this one goes through, and just like the other two, it has a power of 1. Cool. So now we have our function. So we can just call this, I don't know, we can call this f of x. All right. And so we have f of x equals k, right? Because we always have to consider k. And then we just write down what we have: x plus 3, x plus 2, and x minus 2. You don't have to write the power of ones. It's assumed when you don't write them. All right, so now we have to figure out k, right? So the way we do that, we're going to use another given point, right? Which is this point here, which is 0, comma, negative 2. Or sorry, negative 24. Whoa, okay. So then all we're going to do is we're going to input negative 24 in for our output and substitute in 0 for every x variable, right? So we're going to do that, 0, 0, 0. And once you simplify this to its most reduced form, you're going to get, let's see, 6 times, you're going to get negative 12 here. And so then you get k by itself. This will become 12 over 24, which then becomes 1 over 2. Let me check my math on that. Did I do that right? I feel like I did that wrong. Do it. 12? Yes, I did do that wrong. My bad. Okay, switch this. I was like, cool. So this should be, again, divided by negative 12, divided by negative 12. All right, negative 24 divided by negative 12 is 2, right? And so we found our constant k value, so our final answer is going to look like f of x equals 2 times x plus 3, x plus 2 times x minus 2. Look at that. Beautiful polynomial. Fantastic job, everyone. All right, so moving on to the next example. Here, basically, it's the same thing, but has a little bit more complicated stuff. So again, let's identify the x values. So the x values are the roots. Identify its opposite factors. Minus 3. Cool. If it bounces or causes a turn, we know that has a even power. If it goes through or doesn't cause a turn at the 0, then it has a odd or 1 power. And here it bounces or turns at the root, so it's power of 2. So then we have our function. We can call u g of x. We say g of x equals k. We have to figure out k. X plus 4 squared times x minus 1 times x minus 3 squared. Nice. And then now we don't have a intercept, but we have a different point, right? We have this point here, negative 2, negative 4. So we do the same process. We're going to substitute in negative 4 here as our output. And then every time we see an x value, all right, every time we see an x value, we're going to substitute in negative 2. So we write negative 2 in here, negative 2, and then negative 2, right? And let's just do some, oops, that was my little timer to wrap up. Okay, so we have negative 4 is equal to k. We got negative 8 squared times -3 times -5 squared. Yay. And once you get all of that, you're going to get k, and I think you're going to get -300 here. Am I right with that? Yes, you're going to get -300. Cool. Divide by -300, divide by -300. K is going to equal 4 over 300, which is the same, reduced to 1 over 75, right? And so that's our k value. So our final answer is going to be g of x equals 1 over 75 times x plus 4 squared times x minus 1 times x minus 3 squared. Yay! Okay, cool. Beautiful. All right, so that's all you need to know. So in short, when you're creating a formula, identify your roots, identify the opposite factors, identify if it has a power of 1 or a power of 2, and then solve for k by substituting a point that's not one of the x-intercepts. All right, that's it. Good luck.